Introductory Statistics Module 1, Data Collection. We're going to look at Section 1.1, an Introduction to the Practice of Statistics. These are the 5 objectives we will look at in this section. Objective 1, we want to define statistics and statistical thinking. Statistics is the science of collecting, organizing, summarizing, and analyzing information to draw conclusions or to answer questions. In addition, statistics is about providing a measure of confidence in any conclusions. So let's look at data. Data is a fact or proposition used to draw a conclusion or to make a decision. Data can be numerical, such as a height, or non-numerical, like a category, such as gender. Data are powerful and dangerous when misused, when incorrectly obtained or analyzed. For example, a radio or a television talk show regularly asks poll questions in which respondents must call in or use the internet to supply their vote. But most likely the individuals that are going to call in are those who have a strong opinion about the topic. So this group is not likely to be representative of people in general. So the results of the poll are not meaningful. So whenever we look at data, we should be mindful of where it comes from. The variability of data is key. So let's consider your fellow classmates. Is everyone the same height? Does everyone have the same color hair? No, obviously. So the results can vary. The goal, though, is to describe and understand the sources of variation. So let's look at Objective 2. Here we will explain the process of statistics. The entire group of individuals to be studied is called the population. An individual is a person or an object that is a member of the population being studied. And then a sample is a smaller subset of the larger population that's being studied. And here we have a picture that'll let you visualize this. The process of statistics consists of these 4 steps. So we'll look at each of them more carefully. First, we identify the research objective. We want to determine the questions to be answered. The question or questions must be detailed so that it identifies the population that's to be studied and the questions that are to be answered. The second step, we want to collect the information needed to answer the questions that were posed in our first step. So gaining access to the entire population is often difficult and expensive. So when conducting research, we typically look at a sample or smaller subset. The third step is to describe the data. So a statistic is a numerical summary based on a sample. Descriptive statistics consists of organizing and summarizing the information collected. This describes information that's collected through numerical measurements, charts, graphs, and tables. The fourth step, we want to perform inference. Inferential statistics uses methods that take results obtained from a sample and extends them to the population, and then measures the reliability of the result. A parameter is a numerical summary of a population. So let's look at the difference now between a parameter versus a statistic. Suppose the percentage of all students on your campus who have a job is 84.9%. This value then represents a parameter because it's a numerical summary coming from the entire population. Suppose we look at a smaller sample of only 250 students. And from this sample, we find that 86.4% have a job. This value represents a statistic because it is a numerical summary based on a sample. And you'll notice the two values are fairly close. So it's not too big of a stretch to look at our smaller sample and apply the result to the larger population. In this example, we're going to look at the entire process of statistic and identify each piece. So, a news service conducted a survey of 1,001 adults aged 18 years or older in a certain country, using the dates August 31st through September 2nd, 2009. The respondents were asked, of every tax dollar that goes to the federal government, how many cents of each dollar would you say are wasted? Of those 1,001 individuals surveyed, 38% indicated that 51 cents or more is wasted. The news service reported that 38% of all adults in the country 18 years or older believe the federal government wastes at least 51 cents of each dollar spent, with a margin of error of 5% and a 95% level of confidence. Some of the language used in this example we will study later. So for our purposes, we are simply identifying the parts that relate to the process of statistics. So first, we want to identify the research objective. Notice that the objective was to determine the proportion of adults in the country who believe the federal government wastes 51 cents or more of every dollar. We can tell this based on the question that was being asked. So now let's answer the question, what is the population? Remember, the population is the large group. So this would be all of the adults in the country aged 18 years or older. Now let's identify the sample. Remember, this is a smaller subset of the population. So that would be the 1,001 adults in the country that were actually surveyed. That is our sample. Now we want to list the descriptive statistics. Remember, the descriptive statistics consist of organizing and summarizing data. They describe data through numerical summaries. So the descriptive statistics is that about 38% of the individuals surveyed indicated that 51 cents or more is wasted. And remember that this is coming from our statistic, which comes from the sample. So then what can be inferred from this survey? This is where we draw a connection from the sample to the population. The news service is 95% certain that the percentage of all adults in the country who believe the federal government wastes 51 cents or more of every dollar received is between 33% and 43%. And notice those numbers come from taking our 38% and adding and subtracting the margin of error, the 5%. Objective 3, we want to distinguish between qualitative and quantitative variables. Variables are the characteristics of the individuals within a population. They can be classified into the two groups, qualitative or categorical variables and quantitative or numerical variables. So qualitative variables allow for classification of individuals based on some attribute or characteristic. An example would be gender, like male or female. Quantitative variables provide numerical measures of individuals. Arithmetic operations, such as addition and subtraction, can be performed on the values and will provide meaningful results. So an example would be temperature. It's numeric, and addition and subtraction make sense and provide meaningful results. So in this example, we want to distinguish between the two types of variables. In this study, our researcher and others studied factors that affect the eating habits of adults in their mid-30s. So we want to classify each of the following variables considered in the study as either qualitative or quantitative. The first was nationality. A person's nationality is just a category, so this would be qualitative. Number of children, this is a numeric value, so this would be quantitative. Next is household income in the previous year. Again, this is a numerical value, so this would be quantitative. Next is level of education. Again, this is simply a category. What particular degree did they have? So that would be qualitative. The daily intake of whole grains measured in grams per day. This is a numeric value, so it's quantitative. In Objective 4, we want to distinguish between discrete and continuous variables. A discrete variable is a quantitative variable, so it's a number, that has either a finite number of possible values or a countable number of possible values. Countable means the values result from counting, such as 0, 1, 2, 3, and so on. So you can't have numbers between those, no decimal values. A continuous variable is a quantitative variable, so another number, but this one has an infinite number of possible values that are not countable. So now we have the decimal values. So think about between the numbers 1 and 2. If we look at all the possible decimals that fall between there, there's an infinite number of possibilities. This gives a good visualization of how these variables compare. We have the qualitative and quantitative, and under the numerical or quantitative variables we can further break them down to either discrete, countable variables, or continuous variables. In this example, we want to determine whether the following variables are discrete or continuous. So the number of heads obtained from flipping a coin 5 times. This would be discrete since we can do it 1, 2, 3, 4, or 5 times. We can count them. The number of cars that arrive at a McDonald's drive-thru between 12 and 1 p.m. This is again a countable number since we can't have partial cars pulling in, so it would be discrete. The distance a car can travel in city driving conditions with a full tank of gas. Here we can have partial values or decimal values, so this would be continuous. In Objective 5, we want to determine the level of measurement of a variable. The first type is the nominal level of measurement. These tend to name, label, or categorize. Also, the naming scheme does not allow for the values to be arranged in any kind of a ranking or specific order. The next level is ordinal. It builds on the nominal level, so it has the same properties as nominal level. However, now the naming scheme allows for the values of the variable to be arranged in a ranking or specific order. The interval level of measurement builds on ordinal, and the differences in the values of the variable have meaning. Also, in this level of measurement, a value of 0 doesn't mean the absence of the quantity. One example there would be temperature. If we have 0 degrees, it doesn't mean there's no temperature. Also, arithmetic operations such as addition and subtraction can be performed. The last level is the ratio level. It has all the properties of the interval level, and the ratios now of the values have meaning. Also, a value of 0 does mean the absence of the quantity. So for instance, if you have been present 0 days, then you haven't been present. Also, arithmetic operations such as multiplication and division can be performed. So let's look at now determining what level of measurement we have for our variables. We're looking at a study that's conducted to assess school eating patterns in high schools in the United States. It analyzed the impact of vending machines and school policies on student food consumption. Total of 1,088 students in 20 schools were surveyed. So we want to determine the level of measurement of the following variables that were considered in the study. First, the number of snack and soft drink vending machines that are in the school. This would be ratio level of measurement, since ratios of our variable have meaning, and having 0 machines meant that there were none there. The next variable is whether or not the school has a closed campus policy during lunch. Either they do or don't, so this is a category. So this would be nominal. We're simply naming the policy, and it does not have any innate ranking. The next variable is class rank, freshman, sophomore, junior, or senior. We're naming them, but we can also put them in a ranking order. So this would be ordinal level. And the last variable is the number of days per week a student eats school lunch. Again, this would be ratio, since we can take ratios of the values and they make sense, but also a value of 0 in this case would mean that there were 0 days that they ate lunch. So it is an absence of the variable.